You are listening to The Vocal Technologist. Spoken tech for your ears.
If you, like me, tried to take maybe a week off and came back to find that the entire artificial intelligence landscape had just been completely reshaped,
Right.
you get it. You get the pace we're at. It feels less like a technology race and more of a, I don't know, a corporate sprinting marathon where the finish line just keeps moving.
It's constantly moving.
Welcome back. Here at The Vocal Technologist, we're going to try and catch you up on the handful of breakthroughs that really actually matter from the last few days.
It is a bewildering time, for sure, but we're here to give you that shortcut. Today, we're really going to examine the high-stakes competitive pressures, right? The big battle between OpenAI, Google, Anthropic, and connect those corporate moves directly to the huge technical shifts we're seeing.
Okay, so like new chips, new architectures, all that.
All of it, and especially why something called agentic safety is now maybe the #1 engineering challenge out there.
Okay, let's break this down then. For you, the listener, we're kind of looking at this through two main tensions. First, you've got the brutal, immediate fight for market share.
The dollars and users.
Exactly. And second, there's this quieter, much more complex struggle between, what the tech can do and the real-world safety, the implementation, and even the human costs that come with it.
Let's start with the battleground.
Yeah, let's jump right in because the atmosphere is it's electric. Google's release of Gemini 3 was so fast and so well received that it apparently triggered a code red inside OpenAI.
A code red. I mean, that's the language of panic.
It's not routine competition, is it?
No, not at all. And if you look at the numbers, you can see why they're feeling the pressure. I mean, ChatGPT is still the leader, over 800 million weekly users.
Still huge.
But Gemini was already at 650 million way back in October, and it's gaining on them fast. That kind of pace, that forces a crisis meeting.
And the immediate result of that meeting is fascinating. OpenAI is reportedly delaying big advertising plans, other product rollouts.
They're basically sacrificing short-term money just to focus all their resources on making ChatGPT's core performance better. They're telling the market, loud and clear, that they prioritize the product mode over how fast they can monetize.
Because they know the users will just leave.
Exactly. They know if they lose that performance lead, that user base is so fickle.
Meanwhile, you've got Anthropic, and they seem to be playing a totally different game. It's maybe a riskier long game.
Yeah, focused on capital and cautious growth. But what's so interesting is the potential contradiction in their strategy.
How so?
Well, on one hand, you have the CEO, Dario Amodei, saying publicly that some AI firms are taking on way too much risk with, just reckless spending on compute.
Okay.
But on the other hand, Anthropic itself is exploring either private funding or what could be one of the largest IPOs ever.
So if they're out there preaching caution, doesn't a multi-billion-dollar IPO kind of fly in the face of that? Are they just talking safety but secretly getting ready to spend like crazy?
Well, it suggests they think they can get the firepower they need without sacrificing their safety-first principles.
Unlike their competitors.
Right. They're focusing their investment really heavily on their enterprise business, which is, more controlled environment. They can control the data, the use cases. It's a risk management play that just looks like a financial one.
And speaking of that kind of infrastructure, they made that acquisition of Bun, the JavaScript runtime.
Yes, which is a really strategic move.
But why does a giant LLM company need a super fast JavaScript runtime? It seems a bit in the weeds.
Because speed is everything in the enterprise. Latency is the enemy. If you're building complex AI apps on their Claude model, especially sophisticated agents, you need execution to be near instant.
Okay.
So acquiring Bun gives them control over the whole developer stack, from the model all the way up to the application layer. It's a very smart move.
That makes perfect sense. Okay, so while the giants are having these existential corporate battles, we have to talk about the open source challenger in the room, Mistral. They just dropped Mistral 3, and the real headline there was Mistral Large.
That immediately forces us to look at where the architecture is going. Because Mistral Large 3 is what's called a sparse mixture of experts, or MoE model.
Okay.
And the numbers are they're staggering. It is 41 billion active parameters, but a total parameter count of 675 billion.
And it's all open source. What does putting something that powerful out there under a permissive license like Apache 2.0, what does that do to the closed source players?
Well, it's a strategic landmine for them.
Yeah.
It creates this massive gravity for talent and for innovation.
Right.
By open sourcing a model this good, Mistral makes sure that thousands of developers outside the big labs are all working on, iterating on, and finding uses for their architecture. It's a kind of asymmetric attack on the big guy's ecosystem.
And that MoE architecture you mentioned, that brings us right back to hardware, doesn't it?
It leads us directly into the infrastructure reality, absolutely.
Hmm.
Because these sparse models, they depend on hardware that can efficiently light up just the tiny part of the model you need at any given moment. And what's fascinating is NVIDIA's response to this exact trend.
So Mistral just threw down the gauntlet with this MoE architecture. Is the hardware actually ready to handle that kind of scale?
The answer is a very dramatic yes. NVIDIA just announced a massive performance breakthrough with their new GB200 Blackwell configuration.
Okay.
They achieved a factor of 10, a 10x leap in performance on MoE models compared to their last generation, the Hopper.
10 times. That sounds like a marketing number. What's the actual engineering that allows for that kind of jump, especially one that's optimized for MoE?
So it's not just about, raw compute. It's all about interconnectivity and memory bandwidth. The Blackwell architecture was specifically built to address the challenge of routing information between all those different experts in the model.
Yeah.
They've built in these specialized interconnects, dedicated optimization layers that let the system shuffle data around to the right nodes without the huge latency bottlenecks you'd get on older systems. This isn't just a small improvement. It basically confirms the economic viability of these massive MoE models.
Which makes Mistral's open source release suddenly 10 times more powerful almost overnight.
Exactly.
And speaking of, putting this stuff to work, we're seeing new services pop up for companies that want a bespoke model but can't, train a 675 billion parameter model from scratch.
And that's exactly where something like Amazon NovaForge comes in.
Okay.
It's designed for organizations with deep proprietary data. Think like a specialized law firm or a pharma company. Instead of starting from zero, they use NovaForge to blend their unique data with Amazon's data, starting from these pre-trained early model checkpoints.
So why does that matter to, say, a technologist listening right now? Is this just another fine-tuning service?
No, it's about building a unique competitive moat and doing it fast. Training a foundational model from scratch is just prohibitively expensive. We're talking months, millions of dollars.
Right.
NovaForge lets them skip that huge initial hurdle, giving them this massive head start with a secure, domain-aware model that's already hosted on AWS.
So this is where the huge leap in capability creates this equally huge challenge of responsibility. As these models get good enough to generate autonomous or agentic code, the need for safety verification just skyrockets. We're moving from, is the code elegant to is the code actually safe?
Absolutely. And AI coding systems are, unfortunately, introducing some pretty severe bugs and vulnerabilities into the software supply chain.
Yeah.
So as the models get better at writing code, their ability to then verify and critique that code has to scale right along with them.
I know OpenAI is working on this with an agentic code reviewer. What's the philosophy behind that?
They're optimizing for what they call high precision and low safety tax.
A low safety tax, what does that mean?
It means the system has to give you really reliable feedback. It has to be right when it flags a bug, but it has to do it without slowing down the development team too much. That's the low safety tax. It's this necessary concession. If the safety process is too slow or too annoying, engineers will just work around it, and then the whole system is useless. It has to be helpful and fast.
That makes sense. It has to earn their trust. And we are seeing this whole field of specialized agents pop up on both the offensive and defensive sides of security.
We are. On the offensive side, you've got something called Raptor.
Raptor?
The Recursive Autonomous Penetration Testing and Observation Robot. It's an open source framework that uses agentic automation to understand a code base, prove an exploit is real, and then autonomously propose a patch to fix it.
So it's not just finding the hole, it's telling you exactly how to fill it.
Exactly. The level of autonomy there is groundbreaking.
And on the other side, for defense, we've got something like Perplexity's BrowseSafe.
Right, and BrowseSafe solves a very specific, very modern problem for these agents. It's an open source model designed to protect an AI agent from prompt injection while it's browsing the web.
How does that work?
So if an agent is autonomously browsing a malicious website, BrowseSafe scans the HTML code in real time, looking for hidden malicious instructions. And crucially, it does this with no performance hit, giving you this vital layer of defense.
Okay, so if we tie all this back to the big picture, we're seeing that the fundamental way people are even using this tech has changed just in the last year.
It's changed dramatically. There was that massive study. It analyzed over 100 trillion tokens of real-world AI interactions.
And that study showed that the field has moved away from simple, single pass generation, like asking for a quick summary,
Right.
to now complex, multi-step deliberation. We are asking these models to do much harder, longer, more consequential work.
We're asking them to be a planner, a collaborator, not just a fancy calculator. And this leads us to the unexpected human cost of all that efficiency, which Anthropic's internal study on their own engineers just highlighted perfectly.
This was the finding that just stopped me cold. Anthropic surveyed 132 of their own engineers, and they found that 27% of the work being done with their AI, Claude, would not have happened otherwise.
It's a massive boost in capacity.
A huge boost. But what's the trade-off?
The trade-off is striking. Mentorship is declining, and it's declining rapidly, because Claude is now the first stop for basic engineering questions, not a senior engineer.
Right.
It's the productivity paradox. You get all this new output, but you lose the traditional ways that skills get transferred.
That mentorship statistic is so profound. I mean, 10 years ago, the only way to debug something really complex was to sit next to a senior dev. Now the first question goes straight to the model. And the engineers themselves are worried. They're worried that the skills you need to supervise or critique the AI's output are the same skills that are, atrophying because you're overusing the AI.
If you always rely on the AI to spot the mistake, you eventually lose the ability to spot it yourself. And this need for speed and reliability, it brings us back to a core engineering challenge.
It is.
It's something called context plumbing.
Context plumbing, that sounds counterintuitive. I thought we spent years trying to cram more and more context into the prompt window. Why is the focus now on removing complexity?
Because the models are so capable now, the biggest performance gains are found just by getting out of their way.
Oh, okay.
Context plumbing means building these pipes that continuously flow the absolute minimal effective context required for a task. Instead of forcing an agent to search a massive stale memory archive for every little query, you build a real-time data pipeline that just feeds it what it needs when it needs it.
So you're reducing latency and the cognitive load on the model itself.
Exactly. It can focus on reasoning, not retrieval.
Okay, finally, let's wrap this all up with the big investment dilemma, the sort of financial paradox that's driving this entire industry right now. We know that AI capital expenditure is like the primary driver of U.S. GDP growth at the moment. The investment is massive.
It is, but there's a looming $1.5 trillion AI revenue shortfall compared to all the capital that's been invested. We need to really ask why the external monetization models are failing so badly compared to the huge internal spending by the Magnificent Seven.
So what's stopping that bubble from just bursting right now?
It's the heavy internal workloads of those same big tech companies. They're spending trillions on GPUs, yes, but they're also consuming all that capacity themselves.
Could do what?
Optimizing search, running internal code generation, improving their own cloud services. The business model for actually selling that capacity to the outside world just hasn't materialized fast enough to justify the spending. It suggests that while the technology is transformative, the external business model is still incredibly uncertain.
So what does this all mean for you, the listener? We've seen this incredibly fierce corporate battle driving breakthroughs in architecture, forcing these huge infrastructure leaps like Nvidia's 10x gain, and creating these complex new safety requirements.
Right, from agentic code reviewers to defensive tools like BrowseSafe.
The key is to understand that this shift to multi-step deliberation means these tools are now essential collaborators.
They are. But we have to think about the long-term implication of that Anthropic study. If AI is driving all this growth, but 27% of the work is brand new, what happens when the human judgment we need to supervise systems like Raptor and these agentic reviewers, what happens when that just atrophies?
We get a huge productivity gain now, but what's the cost in 5 years when the human supervisors lack the critical skills to know when the system is just fundamentally wrong? That's the critical question, isn't it?
It is.
Thank you for joining us for this look at the frontier AI race. We'll continue this pursuit of knowledge next time, right here.
Spoken Tech, for your ears.